Hello friends, today we're going to solve as many problems as we can in GRE geometry questions. So for this problem we are asked what is the area of the triangle ABC. So if you look at this carefully, you can see that this angle has to be 60 degrees, right? And AC, we can denote AC as X. What's the area of a triangle? The area of a triangle is half times base times height. So this is simply 1 over 2 times the base is x, the height is 6. And with this, we'll find that the area is simply 3x. But we do not know what x is, so we're going to find that out. And to do so, we look at special triangles. So this is triangle 1 and this is triangle 2. These are special triangles. So this is right angle and the other angles are 45 degrees. So you have the sides being in this form: root 2, 1, and 1. Okay, this is what it is. So for example, if this is A, this means this will be A and this will be root 2 times A. So that's why I just made it 1 at this point. Okay, so this is root 2, 1, 1. And for triangle 2, which has angle 90 degrees, 60 and 30. So the hypotenuse is 2. The side opposite 60 degrees will be root 3, and the side opposite 30 degrees is going to be 1. So we're going to use this to find what our x is. So let's look at our own triangle. The side facing 30 degrees is 6, and the side facing 60 degrees is x. Let's compare this with triangle 2. The side facing 30 degrees here, that is 1, and the side facing 60 degrees is root 3. We know that already. So with this, we can cross multiply. This will now give us that x times 1 is x, and 6 times root 3 is 6 root 3. That simply means that this is our x, right? And let me put that back in our area. So area is simply going to be 3 times x, but this will be 3 times 6 root 3, which is simply 18 root 3. So the solution here is D. And if you have problem understanding this concept, you can let me know in the comment section. I can make just a single video explaining this special triangle. We're given that the volume V of a right circular cylinder is pi r squared h, where r is the radius of the base and h is the height of the cylinder. So we are given that V is simply pi r squared h. Okay, and if the volume of the right circular cylinder is 45 pi, so that means V is 45 pi, so we can replace this with 45 pi, and this is equals to pi r squared h, and the height h is 5, so I can easily replace this height here with 5. Okay, what is the circumference of the base of what is the circumference of its base? So that means what we are looking for here is just 2 pi r. So we have to find what r is, and we can find that out from what we have here. So we can divide both sides by 5 pi, 5 pi. Let me clean this up. And this cancels this, this cancels this. We have 9. This cancels this, this cancels this. So we have is 9 is equals to r squared. And if I find the square root of both sides, I'll find that r is simply 3. So I immediately put that here. We have that 2 pi r, which is 2 pi times 3, and this is simply 6 pi. And that is your solution. So the answer here is D. For this GRE problem, we are asked to find the area of the shaded portion, but we are also told that the area of the square is 16. So what that means is that if the area of the square is 16, that means the sides of the square has to be 4, because the area of a square is simply L squared, and this is 16. That means we'll find the square root of both sides. L is equals to 4. That means each of the sides of the square is equals to 4, right? But how exactly do we find the shaded region? We're going to find this region here, by the logic here is we'll find the area of the entire circle, then we'll subtract the area of the square, which is given to us as 16. So what will now be left will be, if we subtract the area of the square, we'll now have the area of all the shaded region. Then whatever we have here, we divide it by 4. That will be equals to just one shaded region, which is what we're looking for. So that's the logic, and I'm going to write that down. Good. But here we know the area of the square, but we don't know the area of the circle. And what is the area of a circle? Area of a circle is simply pi r squared, but we don't know what r is, but we can find that. And if you look at this drawing, I'm just going to clean some of these fours out. You can see that this line, this is the diameter of this circle. And from here, we can pull out this triangle, right? I'm just going to redraw that out here. So this is the triangle we are looking at here. This is 4, this is 4, and this is D, the diameter of the circle. And this is an angle 90 degrees. So what is D? By Pythagoras theorem, D is simply square root of 4 squared plus 4 squared, which is D is equals to square root of 16 plus 16, which means D is equals to the square root of 16 times 2, which means that is the square root of 16 times square root of 2, which means D is simply 4 root 2. Okay, that's our diameter, D. So this is 4 root 2. And if D is 4 root 2, R radius is simply D over 2, which is 4 root 2 over 2, which is 2 root 2. Okay, so with this, we now have our radius. We can easily solve for our shaded region. Okay, so that means the area of our shaded, I'm just going to put it this way, is simply going to be area of the circle, which is pi r squared, minus area of the square, which is 16 over 4. So this is simply pi times, what's our r? Our r is 2 root 2 squared minus 16 all over 4. Okay, so this is equals to pi 2 root 2 to the power of 2. That is simply times 2 times root 2 times 2 times root 2 minus 16 all over 4. Don't mind me, I'm doing it this long way so that everyone understands. This is equals to 2 times 2 is 4, root 2 times root 2 is 2. So we have pi times 4 times 2 minus, what is 16? 16 is 4 times 4, right? All over 4. So here we can factor out 4 here. So this is simply going to give us 4 into 2 pi minus 4 all over 4, right? So I'm factored out this 4. So 4 can cancel 4, and what we'll have left is simply 2 pi minus 4. And this is the area of the shaded region. So let's look back here. So 2 pi minus 4 is option B, and that is the correct answer. For this question, we are given that the radius of circle A is R. And so let me write it out here. Radius of circle A is R, and the radius of circle B is 3 over 4R. Okay, what is the ratio of the area of circle A to the area of circle B? Which is easy. So what's the area of a circle? That is pi r squared, right? So this will be pi r a squared is to pi r b squared. Okay, and this is simply pi r a is just r squared is to pi r b is 3 over 4 r squared, right? And this is simply pi r squared is to pi 9 over 16 r squared. We can divide both sides by pi r squared divided by pi r squared. This cancel this cancel this. So we have here 1 is 2, this cancel this cancel this. 1 is to 9 over 16. If we multiply both sides by 16, we're going to have that this will be 1 times 16 is 16. 9 over 16 times 16 is simply 9. So the ratio is 16 is to 9. And answer E is the correct answer. Last but not the least, we're given that the quadrants of the XY plane are shown in the figure above. In the XY plane, line M not shown has a positive slope. So let's stop here. How do we know a positive slope? So if we have our XY plane here, a positive slope, the part tending up, the upper part of the slope has to tend towards the right. What do I mean? A positive slope has to be like this. It could be in any form because the upper part is tending towards the right. That's just an easy way to know that it's a positive slope. So we have an idea what M should look like. What else do we know? And a positive x-intercept. So here is our x, positive x coordinate. So that means it intersects somewhere. We could just pick any point here. Okay, so what's the question? Line M intersects which of these quadrants? So that means it intersects here. So line M could just be a line of this nature. And as we can see, it intersects quadrant I, quadrant IV, and quadrant III, but not quadrant this. It does not intersect this. So that simply means that it intersects this, and this. And so that is the answer. A, C, D is the correct answer.